The rest of the world is watching. This isn't just about Australia. Yeah. This is an experiment that is playing out in the rest of the world. It's a petri dish, and the rest of the world is watching it right now to see not only how bad does it get, but what do we do about it?
Hey everyone, Giordano here from the Juice Media. Welcome back to the Juice Media podcast, a companion to the Honest Government Ad series. This is episode 9, which is the second half of our podcast companion for our Honest Government ad about the fires. Just before we get into it, a reminder that we're trying something new out here. Instead of just uploading our podcast to our host, which we'll carry on doing, we're also going to be sticking it up here on YouTube. The reason being that the podcast has become a really rich companion to the Honest Government ads, and I think you would all get a lot out of them. So rather than try and make you all go to another platform, we thought we'd make it easier for everyone to see it and share it. In the first half of this podcast, episode 8, I chatted with Simon Holmes Accord about some of the technological solutions that are available to us right now to avoid epic climate change fail. If you haven't already seen it, check it out. It's getting some really good feedback. But now in the second half, we're going to geek out about the science itself. And yes, I know, on the internet, everyone's a fucking expert about climate change. Why haven't you looked at geoengineering, chemtrails,
Greta Agenda 21?
The thing that's usually lacking in all these conversations is, yep, you guessed it, a climate scientist. So today I'm really proud to have as our guest on this podcast, not just any scientist, but one of the world's most renowned climate scientists, Michael E Mann. For those of you that don't know him, Mann is an American climatologist and geophysicist, currently director of the Earth System Science Center at the Pennsylvania State University. He's basically a pioneer in the field of climate change thanks to his statistical work, which was able to detect the signal of climate change, isolating it from background noise data. These techniques were used by Mann and his colleagues to produce a reconstruction of climate temperatures over the past 1,000 years, which gave birth to a graph that many of you will be familiar with, the hockey stick graph. A lead author of the IPCC's third scientific assessment report, Mann's work has been key to establishing the reality of anthropogenic climate change. It's important to note that because of his central role in all of this, Michael Mann has become a sort of lightning rod and troll magnet, frequently the target of attack from climate deniers who have mounted a campaign to try and discredit him in order to cast doubt over the science. No doubt, in the comment section, there will be people posting links supposedly discrediting him or his work. So I just want to preempt that by saying I'm going to put a couple of links in the video description which set the record straight on these claims. But most importantly, it is important to remember that more than 24 reconstructions using various statistical methods have supported the broad consensus shown in the original hockey stick graph, which Mann co-authored. Because of his experience both as a pioneer climate scientist and also as a lightning rod for assorted pseudoscientific climate change denying fuckwits, Michael Mann has emerged as one of the most important and effective communicators on climate change. He's also got a pretty wicked sense of humour, so when he saw our Honest Government ad about the fires, he loved it and posted it on his Twitter page. A couple of days later, I had the opportunity to meet Michael in person, and after chatting about all sorts of things over several hours, it occurred to me to invite him onto the podcast. I was stoked that a couple of days later, when I followed up with him, he'd neither forgotten nor changed his mind. So welcome to the Juice Media podcast and to Australia, Professor Michael Mann.
Thank you. It's good to be with you.
You've come to the front line of climate change. What have you learned so far on your trip here? We're also the capital of shitfuckery, as you'll find out. But what have you found?
Well, unfortunately, I have found that to be the case. Here, as you allude to, Australia is very clearly on the front lines of dealing with the impacts of climate change. I arrived in mid-December when we were still experiencing that unprecedented drought and heat, and the bushfires were spreading literally around the continent. So Australia, again, quite literally, is on the front lines of dealing with the impacts of climate change. But as you allude to, it's also on the front lines of dealing with climate change denial and delay. And the current government, the Morrison government, has pretty much done everything it can to block any meaningful efforts to actually do something about climate change.
Now, you used the word unprecedented to refer to the Australian fires this summer, but you're wrong about that, Professor Mann. I'm sure you're aware a number of self-appointed experts have been saying that actually fires are just part of the Australian experience, and they point out that there have been bigger fires in the past, such as in 1974.
I can almost hear the open-minded Jim Molins and deniers in our comments yelling, the fires weren't caused by climate change, the juice media is a hoax.
Yeah.
So I thought this would be a great opportunity for them to hear from an actual climate scientist why they're full of shit and why these fires are indeed unprecedented.
Sure, and don't you know that they were all started by arsonists? 157 arsonists who were
busy.
No, it's ridiculous. And of course, the Murdoch media was promoting this false claim that they were started by arson. It was actually dry lightning strikes, natural causes that start these fires. And it doesn't actually matter what starts them when you have the tinderbox-like conditions that we had here in Australia with unprecedented heat and unprecedented drought. And yes, we know that the drought and the heat have no precedent as far back as reliable records go. And it's not rocket science, right? You take unprecedented heat, you combine it with unprecedented drought, you're going to have unprecedented amount of fuel for these fires. Again, tinderbox-like conditions. So if you manage to start a fire, it doesn't matter how it started. The issue is how quickly it spreads, how intense it becomes. That's a function of how warm it is, how dry it is, how much fuel has built up. And that's really what the problem was. We know that there is no precedent for both the combination of intensity, widespreadness, and how quickly these fires spread. When you talk to firefighters, to a person, you hear the same thing, that they've never seen fires that spread this quickly, that become so intense so quickly, that create their own weather to the extent that these fires have. They're qualitatively different from the fires that we've seen before. And what's changed? What's changed is that we're warming up the planet, we're warming up the continent, we're drying it out. There are other factors that come into it. People may have heard of the Indian Ocean Dipole, which is a fancy term for just how sea surface temperatures oscillate in the Indian Ocean, and that can have an impact on Australian summer climate. And in this very strong positive phase, as we call it, of the Indian Ocean Dipole, contributed to the extreme dry conditions. But look, those natural factors have acted over millennia. What's different is the overall heating and the drying that's creating. And so you take the natural factors, the natural oscillations, you put it on top of this ever-rising ramp of hotter and drier conditions, and you're going to get unprecedented wildfires. And by the way, there is no evidence that we have seen such widespread bushfires in Australia before. And what the critics will do, for example, is they'll try to combine grass fires in the north with these massive bushfires that we're seeing here in New South Wales and Victoria. And those are completely different kinds of fires. These grass fires.
That's like the 1974 fire, which is
right.
That's the example that a lot of people have been raising.
Yeah, exactly. Those are a completely different type of fire. These grass fires, happen naturally, and they can happen over very large expanses of grassland and shrubs. But the forest burning that we've seen, and this unprecedented destruction of our forests and the wildlife that they are home to, that is unprecedented. We've seen regions experiencing bushfires that have never experienced bushfires before, regions that are generally some of the moister tropical regions of Australia where, they don't have, at least in the past, haven't seen bushfires, and they're seeing them now. So, make no mistake about it. This is unprecedented, and we know why it's happening. And I hate to say we told you so, but look, we told you so. Ross Garnaut, a well-known economist and an expert on sort of climate change impacts, was the lead author of a report that came out in 2008, which has gotten a lot of attention because there's literally a line in that report that says, look, if we continue on the course that we're on, the fire season will get longer, the fires will get more intense. And by the way, we expect that this will become obvious by 2020. And here we are. And you know what? It's become obvious.
Well, it didn't specify the month, so it wasn't exactly on
or the
on
day.
point.
He thought
Exactly.
about it, but he tried to leave a little
Yeah.
wiggle room in there. Yeah.
So clearly another hoax. You told me you're literally here on sabbatical to study the effects of climate change, and then, like as if on cue, the whole fucking country bursts into fire. Are you integrating this into your work? Are you updating your understanding of the effects of climate change, or is this just exactly what everyone expected in the climate science community?
No, it's what we predicted, but not what we expected, which is, to say that, decades ago we said this sort of stuff will happen if we don't act. And of course, we've failed to act in a meaningful way, and we're seeing it play out. Now, this experience can't help but impact and influence me in my speaking and my writing. I've written quite about this, what's unfolding in Australia, not just on the impacts of climate change, but on the denialism from the government and the role of the Murdoch media that has polluted not just our atmosphere by denying climate change, but it's polluted the public discourse over climate in this country and elsewhere around the world. So I came here to do science, but I arrived at a unique time and instead find myself doing quite a bit of outreach, trying to, it's a terrible tragedy we're seeing play out, and yet it does provide a teaching opportunity to explain to people the real cost of inaction on climate. And I'm in the middle of writing my next book, which is about the climate wars. It's how to win the new climate war. And it's about how we've sort of shifted away largely from outright denial that it's happening to sort of softer forms of denial, efforts to delay, deflect, doomism, i.e., well, it's too late to do anything about it, so why even bother try, is another avenue in sort of this multi-pronged effort to block action on climate. And here in Australia, again, we're on the front lines of all of that. And so it's influencing my writing. The book that I'm writing is a very different book from the book I would have written had I not been spending this time in Australia. And of course, again, I'm spending much of my time talking to journalists, doing media, because there's a unique opportunity that the rest of the world is watching. This isn't just about Australia. Yeah. This is an experiment that is playing out in the rest of the world. It's a petri dish, and the rest of the world is watching it right now to see not only how bad does it get, but what do we do about it? Will we see the sort of shift, the sort of tipping point in consciousness in this country that will, lead us away from denial and delay towards action? Will we see that happen now? And if so, I think we are seeing a shift in sort of the nature of the conversation. And to the extent that we do, it maybe will signal to the rest of the world that we are indeed ready to move on. But, we're not without some major obstacles, one of which is the prevailing politics. And here in Australia, this is a vivid example of that.
I mean, and it's becoming very clear that really is the only remaining obstacle is the politics. In part one of this podcast, I spoke with Simon Holmes Accord, and the technology is there. There's so many options ready to go. Now, I wanted to ask you a couple of geeky questions about climate scientists, because I find this really frustrating. I don't know about you, but anytime there is like a conference or an interview or anything like that with a climate scientist, it inevitably gets bogged down in dealing with the narrative of climate denial. And that's important. But what ends up happening is that sets the frame of the discussion, and the Overton window gets stuck in that. How do we debate this issue rather than getting onto the science and what do we actually need to do to get out of this shit show? So I want to ask you in a second about actually the science, but just so that we get it out of the way, because we do, as any online show, we do have a lot of people in our audience that are like, climate scientists are all bored out. There's like a million, the climate's always changing. What do you make of it as a climate scientist? I mean, is it exasperating that there is this sort of anti-intellectual movement, or do you feel like some of these arguments or criticisms are valid and it's important to address them? What's your take on it?
Yeah, these climate scientists are just an awful bunch. Wait a second. I'm one of them, aren't I? No, this is sort of part and parcel to the culture of science. Scientists are intrinsically very conservative, very reticent to venture outside of sort of the technical discussions, the science itself. And in the environment we live in today, where if you sort of connect the dots for the public, you'll be vilified on the pages of The Australian. You'll be attacked by the Murdoch media. That's understandably led scientists to sort of, to some extent, to withdraw from the public conversation. That's the intent of these attacks, to lead the scientific community to withdraw from the conversation. That then leaves behind a vacuum that is readily filled by the forces of denial and delay, the Murdoch media, et cetera. So part of what I see my role as being today, I didn't have that luxury when we published the hockey stick curve 2 decades ago, and it became this sort of icon in the climate change debate, and I found myself under attack. It was sort of sink or swim. I had to figure out how to defend myself and to defend my work against these these bad faith assaults by conservative media and politicians looking to discredit the case for concern about climate change. And ultimately, I learned how to sort of be more effective in the public sphere. And that's led me now, ultimately to embrace this role that I have, that I'm playing now, of trying to explain the science and its implications to the public and policymakers. But part of what I hope I'm doing is helping set an example for other scientists, particularly younger scientists, that, that this is important. This is something we need to do. And I'm not saying every scientist should be out there talking to the media. I know some who should never talk to the media. I know some scientists who are best left alone in the laboratory, probably not even interacting with other human beings if possible. We all know those scientists, but there's going to be some subset of scientists, as there is with any group, have a proclivity and an interest in communicating the science and its implications. And we have to create space and we have to provide incentives for scientists to do that. And I feel like part of my role today is to help do that, not just to communicate myself, but to create an atmosphere, especially here in Australia, where I think the scientists feel very intimidated. They're afraid of being attacked by the Murdoch media if they, again, talk about the crisis, talk about the problem in stark terms. And, they derive their funding from the government, and we have a conservative government that hasn't been very supportive of the science. So for various means, I think that scientists in Australia in particular have been very reticent, and I think that's starting to change, and I hope maybe I'm playing some sort of role in changing the culture here so scientists feel more comfortable in doing that.
As I said in a tweet response, you saw our video about the fires, and I was really stoked when you retweeted it, and I got some messages from people going, "Holy shit, Michael Mann has retweeted your video." I responded saying,
"It was masterful
thanks.
stuff. It was my honor to do so."
Thank you. But I responded to you saying thanks for the work that you're doing here, and I think you'll leave us stronger than when you found us, because of the contribution that you've made to the public discourse here. You're going to inspire and embolden a lot of people, scientists.
Well, right back at you, mate.
Scientists, but I think also general public. And I remember when I've been making videos now for about 10 years. The Honest Government Ad series is a little bit younger. We started about 3 years ago, but I used to dread talking about climate. I mean, I did it anyway, but I used to talk about climate change, and not many comedians and satirists. It wasn't a topic that a lot of people engaged in, because it was just a magnet for hate and trolls and dickheads. Once you get used to it, like, you just go, well, this is part of the reality of dealing with the subject. The hate that comes back, you actually kind of normalize it a little bit. It's not a nice thing, but you kind of develop a bit of a thicker skin. And now I relish. This is my favorite topic of conversation for the videos that we make, partly because it's a challenge. Like, we're devising, I think, original ways of dealing with the topic, talking about climate change within a satirical frame, which is not something that a lot of comedians do. And partly, of course, because it's such an important topic. And so, for better or worse, the hate is just something. The fact that we have to deal with this is kind of like part and parcel of it. So thank you for for setting that example and sticking your neck out.
Welcome to the battle, my friend. We're very happy to have you on our side here. As
I said, I want to kind of actually move the discussion window And because I always go, we should stop wasting our time debating conspiracy theories that are never ending. We don't have time for that anymore. Climate deniers have had decades to prove their case. We've listened to them. We've gone through it all. Fuck it now. So I wanted to ask you a couple of practical questions. For example, how does one become a climate scientist? There are people listening who are interested in this field, and particularly young people. There might be some students. Students are really engaged at the moment, especially here in Australia with the climate strike movement. And many of them might be wondering, how do they become a climate scientist? What can they study? What are the pathways to follow? Because your qualifications might be different to those of another climate scientist, and yet you share that label. How does one actually get into this field or discipline?
Yeah. Well, I can't go into the details for obvious reasons, but it does involve a ceremony with whips and farm animals. I
knew it.
Yeah,
I was just getting us away from the conspiracies, and now you've taken us straight back. Thanks.
No, it's scientists come into this field from a lot of different directions because it's intrinsically interdisciplinary, which is to say, there's physics, there's chemistry, there's biology, there is hydrology, there is ultimately, when you look at the larger problem, there's economics, there's philosophy. I mean, every discipline that exists in academia, including history, which is the discipline you come from, has a role in informing the larger climate issue. So scientists actually come into this field from a variety of directions. I was sort of part of somewhat of a mass exodus from the theoretical physics community in the late 1980s, when funding was sort of drying up in that field, and people like myself, students who had backgrounds in physics and math were sort of looking for new areas where we could bring those tools to bear on working on sort of some of the big wide open problems. And climate science really was it for me. At that time, really the early 90s, when I switched out of physics into geology and geophysics, this was sort of a renaissance where climate modeling was becoming far more sophisticated. There were more powerful supercomputers on which you could run the models. We had all these data coming in that were building a clearer and clearer picture of a planet that's warming up and a climate that's changing, and all of that was really converging. So it was an exciting time. And so you had people like me coming in from physics and math, but you had other people who came in from chemistry and biology, and focused on sort of the chemical and biological elements of the problem, the global carbon cycle, for example. I mean, that's really biology. The greenhouse effect, well, that's chemistry, and atmospheric constituents and the impact they have on the climate, that's chemistry. So it's a mixing bowl. And that was one of the exciting things about climate science, that it was this mixing bowl, and that you had people coming into it from different fields, and you learned quite a bit. You learned quite a bit, not just about your own sort of narrow area of research, but by interacting with scientists coming in from a broad variety of disciplines. You became more interdisciplinary. You became broader in your understanding of science as a climate scientist, simply because of the culture that existed at that time. And so it was an exciting time to be part of that, and it was an interesting time in that it was really during that time interval from the late 1980s to the mid 1990s, where the scientific community really did reach a very robust consensus that climate change is real and human caused. And yet you're absolutely right. Decades later, we're still forced to entertain, in some circles, debates about the science when the essentials were settled decades ago.
You mentioned that, I come from the field of history, but hearing you speak the other day about your research, with the hockey stick graph, you're a historian too. I mean, you're one of the most ancient historians, in the sense that you have documented the famous hockey graph, which here I am trying to explain it to you. But can you explain a little bit what your key finding was, and how far back you managed to plot temperatures, and also potentially how far we've come since that milestone report that you did with the IPCC in 1998 or so?
Sure. And let me first say that, I did recently I had my birthday here in Australia, and I moved from the early 50s, and now I'm sort of in the mid 50s. But I think ancient is a little unfair. Although my daughter does call me ancient, with good reason. The history of this particular area of the science is now 2 decades old. We published the original hockey stick curve in 1998 in the journal Nature, and then extended it back to the past 1,000 years a year later in a 99 publication and that's sort of the iconic hockey stick curve that you often see, with the sort of slow cooling from the relative warmth of medieval times into the depths of the Little Ice Age, and then the abrupt spike of the past century and a half that is without precedent. That's the blade, if you like, of the hockey stick. And it bespeaks a simple truth that we are engaged in this unprecedented experiment with the planet, and so it did become a lightning rod, to mix metaphors, in the climate change debate. I became an object of attack, people trying to discredit me, to discredit the case for concern about climate change. And that is really ultimately what thrust me right into the center of the fractious public debate about climate change. And I thank my critics for that. Otherwise, I wouldn't be in the position I am now, now to sort of be part of this very important conversation. But decades later, there are now dozens of groups that have gone back and used far more extensive data, more and more sophisticated methods. There's a veritable hockey league, if you will, or a hockey team, which is to say there are many curves of this sort that have now been done. And not only do they all come to the same conclusion about the anomalous nature of the recent warming, some now extend that back literally tens of thousands of years. And so we know now, based on more widespread and far-reaching data, that the warming we're seeing right now is unprecedented in tens of thousands of years, potentially hundreds of thousands of years.
This is the great thing. I mean, what you do and so many other scientists who are good at communicating, you're really good at speaking to the lay community, mere mortals like myself. But for a second, can you just give us a glimpse into, like, if you were speaking with other climate scientists, colleagues at your own kind of level of understanding of the field, could you give us a glimpse into where we are at now in terms of climate change, using the jargon that you need to use in order to make these points, just so people get a sense of how you normally communicate?
Absolutely. Yes, it's a completely different language.
Don't worry about us for a minute.
The basics, so we talk a lot these days about what's known as the climate sensitivity. And there's a lot of discussion about this in the professional literature, the equilibrium climate sensitivity, or ECS. It's a measure of the warming effect of greenhouse gases. And it's defined in this way. If you double the concentration of carbon dioxide in the atmosphere, which we are on our way to doing, pre-industrial levels were about 280 parts per million CO2 in the atmosphere. So they'll be doubled if we get to 560 parts per million CO2 in the atmosphere. And we could reach that easily later this century, in a matter of decades, in fact, if we sort of continue with business as usual burning of fossil fuels, if we don't really, pass policies to curtail the burning of fossil fuels. So the equilibrium climate sensitivity is how much warming does that result in if you double the concentration of CO2 in the atmosphere. And it is a function not just of the direct greenhouse effect, warming effect of CO2, carbon dioxide, which is a greenhouse gas, but it takes into account all of what we call the feedbacks. They're positive feedbacks, and that sounds like a good thing, but it's a bad thing. Positive feedback is an amplifying factor. So you warm up the surface of the oceans, you evaporate more moisture into the atmosphere. So you've got more water vapor in the atmosphere. And water vapor itself is a very potent greenhouse gas. So that adds further to the warming. You melt away snow and ice. That means that the surface underneath is now exposed to the sun, and it absorbs more of the heating by the sun. Another positive feedback. It's the reason for what we call polar amplification, that the polar regions, the Antarctic Peninsula, for example, and the Arctic are both warming up faster than the rest of the planet. In part, it's because of this positive feedback. And so these amplifying factors lead to more warming than you would get if it was just the warming from the carbon dioxide increase alone. Turns out that warming alone would only give you about 1 degree Celsius if you double CO2 concentrations, but the water vapor feedback adds about 2.5 degrees. The ice albedo feedback adds another 0.5 degree, and you pretty soon you're coming up with a number potentially as high as 4 degrees Celsius for that equilibrium climate sensitivity. Now there's a fair amount of uncertainty because there are also some potential negative feedbacks. These would be stabilizing factors. For example, if warming of the surface of the Earth leads to more low clouds sort of behave the same way ice on the surface of the Earth does. The sun from above sees this white reflective surface, which reflects sunlight back to space. So these low clouds can be a cooling effect. And so if a warmer planet has more low clouds, like marine stratocumulus clouds, the low stratus clouds you see off the coast sometimes here in Australia and other coastal regions, if global warming were to lead to more of those, then that could actually be a mitigating factor, a stabilizing factor. So you have to add in all of the positive feedbacks and the negative feedbacks as well. Now, we used to think, again, I've alluded to that clouds might be a negative feedback. But it turns out they can also be a positive feedback because high wispy clouds like cirrus clouds actually absorb some of the heat that's trying to escape from the surface of the planet out to space. They act the same way a greenhouse gas does, and they warm the planet. So you need to know not just will there be more clouds or less clouds, but what kinds of clouds will they be? Will they be low clouds? Will they be high clouds? And so there's a fair amount of uncertainty because no climate model today is going to resolve an individual cloud. It's just too small to account for in a model that's trying to describe the global oceans, the global atmosphere, the ice sheets, and everything else. So you have to make simplifications. You have to use statistical representations that we call parameterizations. And so climate models typically use these parameterizations to represent small-scale features that aren't explicitly resolved by the grid models themselves, like clouds. Now, it turns out there's enough uncertainty in those representations that different modeling groups come to different conclusions. They get different answers. And so there's a pretty large spread, it turns out, in the climate sensitivity that comes out of the various models. Some climate models, in particular because they have clouds behaving as a strong negative feedback, have a climate sensitivity below 3 degrees Celsius. Some, and an increasing number of models, actually have climate sensitivities closer to 5 or even greater than 5 degrees. For a long time, we used to say that our best estimate from all of the collective evidence is a climate sensitivity of about 3 degrees Celsius. You double CO2 concentrations, you wait for the climate to catch up, it'll eventually warm 3 degrees Celsius as a response. Now, increasingly, we can't rule out 4, maybe even 5. It's a classic example of, yes, there's uncertainty. The critics like to talk about the scientific uncertainty as a reason for inaction, but if anything, it's the opposite because the uncertainty is cutting against us. It's not our friend. As we learn more, as we better represent some of these processes and climate models, we're actually moving in the direction of the effect potentially being greater than we thought, the impacts coming sooner, and nowhere else is that more obvious than here in Australia, where dangerous climate change has by some measure already arrived. It isn't 1.5 degrees Celsius, it isn't 2 degrees Celsius. We often hear people talk about these thresholds where we reach dangerous climate change. Here in Australia, we're there. The impacts are now dangerous.
And now we can understand why scientists put that in terms that everyone can understand, because they get a sense of the complexity. But I love that. I yearn for more of that. Like whenever there's a climate scientist at a conference panel or at a rally, we never get to hear about the actual science. And I think that's, I love listening to that. And I think our listeners will too.
Well, thank you so much. You've just provided a perfect segue for me to sell my free online course on climate change, the science and global impact. It's with EDX and the SDG Academy, which is part of the United Nations Sustainability Program. So I have a free course that I designed for people who want to learn more about the science and the impacts and all the other sort of aspects of the problem. And so sign up for it. Google it. It's at EDX. And we've had more than 10,000 people now take the course. In fact, I think it's up to 12,500 now. And it's free. If you want a certificate of completion when you complete the course, it does actually cost $50, but the course itself is free. And you can geek out as much as you want on the science.
That's fantastic. Sorry, what's the address? So we'll put this in the show notes so that people can actually click the link and go directly there. And the URL is?
So it's www.edx.org/course/climate-change-and-global-impact. And that's,
we need to come up with a shorter version of that. But.
Yeah, I know. Well, we should use the bit.ly to shorten that thing, or just Google a freaking thing, you'll find it.
I love that. I wanted to ask you about the US. We did an honest government ad on the fires here in Australia, but at some point we've had so many requests to do an honest government ad about the US climate policy.
Right.
You've seen our video. What would we need to change in order to make this apply to the US?
Yeah, not a whole lot, because it's pretty much the same story. And so it's the same sort of shite F-word curry. I'm not going to say it myself because I'll get in trouble with my family for cursing. So the shit effery is very similar, when it comes to the politics of this issue right now in the United States. And we have an election, fortunately, that comes up sooner, so we can hopefully shift directions, elect a president and a Congress who will actually recognize that we have a problem and do something about it. But, I think that in terms of the environment that exists right now, it's remarkably similar. So if you replace that ad with somebody with a Brooklyn accent or a Texas accent or what have you, I think it would work remarkably well. The basic message is as valid in the States as it is here in Australia.
I'm going to ask you one final question before I let you go. And again, thanks so much for joining us on the podcast.
Sure.
I want to end on a big picture note because I feel like on a subject like this, it's really important to remember the bigger picture. I assume you're familiar with the great filter theory in the context of Fermi's paradox.
I am indeed, yes.
So just for the benefit of our audience, for anyone who is not aware of the great filter, and I really encourage you to Google it, go check it out. There is some amazing stuff written about this. The great filter is one of the possible explanations for Fermi's paradox, which says since we know the universe should be teeming with life, then why haven't we encountered any? And the great filter hypothesis suggests that there is something, we don't know what, but something that prevents civilizations from surviving past a certain level of technological development, which means they end up destroying themselves before they ever have the chance to communicate with any other intelligent civilization, such as ourselves. So given where we find ourselves, do you think climate change is the great filter? Have you thought of climate change in those terms?
I have indeed. In climate change and environmental degradation in general, because of course climate change is just one axis in this multi-dimensional space, which is environmental sustainability. And we are, of course, challenging the ability of this planet to meet our basic resource needs right now. There's no question about it. Now, will that lead to our ultimate demise or even extinction? Who knows? I don't have a crystal ball that I can look into and tell you what will happen in the future. I do know that some of the recent elections, and in particular the election of Donald Trump, I even tweeted at the time that now we know the solution to Fermi's paradox. That's the one piece of
grim
news.
Tweet.
Carl Sagan and others long speculated as to why we haven't heard from intelligent civilizations, which is the Fermi paradox. If the universe is teeming with life, as it ought to be, if you do the calculations, using what's known as the Drake equation. You can think of this as a product of terms. How many, planetary systems are there in the universe? How many are likely to have an Earth-like planet, et cetera, et cetera. And you can sort of think about all these things and come up with an estimate of, what's the likelihood that, there would be intelligent civilizations close enough to each other to actually communicate within their lifetimes, their respective lifetimes. And it turns out one of the critical terms in that equation is how long intelligent life persists, how long intelligent civilizations persist. Do they destroy themselves? This is something that Carl Sagan, other scientists like Frank Drake at the time were very interested in. And I think part of his efforts to evolve from a scientist and a science communicator to an advocate, and he advocated against the arms race back in the 1980s, as the U.S. and Russia were both building their arsenals. So I think one of the things that he recognized was, this could be the explanation of why we haven't heard from other intelligent civilizations. The universe may be teeming with them, but if we all destroy ourselves over a time frame as short as, a few thousand years, then that would explain it potentially. And so I think that it's interesting, the philosophical import of the Drake equation and Fermi's paradox, or if you like, the great filter, actually had an impact on how scientists like Carl Sagan saw their role in the public sphere as not just scientist, not just communicator, but to try to use their knowledge and influence to do everything they can to make sure that we don't go down that path of destruction. And, I think Carl Sagan would be horrified today at where we are, that we've elected a demagogue like Donald Trump to be the president of what is currently, arguably the most powerful country in the world. How dangerous that is, how close we've come. Even if we escape this one, we never should have come so close. That alone deeply chills me. It disturbs me. It says that maybe it's inevitable. Maybe that is our destiny. Maybe that is the explanation to the Fermi paradox. But God, I'll do everything that I can in my life and with whatever influence I have to try to make sure that isn't our legacy. And that's part of why I fight so hard to advocate for an honest discourse over climate change and what to do about it. It's not what I signed up for when I, double majored in applied math and physics in graduate school. Little did I realize that I would be, ultimately inserting myself into the very center of a fractious societal debate. But that's where I found myself, and I've embraced that role.
I just want to say, first of all, you can't take all the credit with Trump for, and being the answer to Fermi's paradox, because Australia's shitfuckery has contributed greatly to this. I mean, we have also sabotaged these climate talks, the whole Kyoto Protocols, the Kyoto Protocol, the credits that we negotiated at that conference that we refused to sign on to. Now we're trying to sabotage it again by trying to claim these phony carbon credits. The shitfuckery, we've played a big role in that. So please give us credit in the end of the species where it's due.
You're absolutely right. It was unfair of me to not recognize the very noble contribution that the Australian government has made to this effort to shit F word the entire planet. So indeed, it's a group effort.
Thank you.
And, a small number of state actors essentially are sabotaging efforts by the rest of the world to do something about this and other environmental problems.
And look, we're going to end it here because I know you're a busy man and climate scientist, and you've got a lot of important work to do. But I just want to make the point that it's really good to end on this big picture note, because it reminds us how much is at stake. This isn't one of the sort of the problems to deal with. This is kind of, Homo sapiens' greatest challenge.
And defining problem of our time.
Yeah, and it's sobering to think that other species, intelligent species around the universe, have probably gone through a similar process of dealing with the same development in terms of technological development, and then having to deal with stupid bullshit conspiracies and arguments that eventually lead to the extinguishment of that whole experiment on that planet. Bye-bye, whatever happened in that galaxy. But now it's our turn, and can we pass this test?
You're right. There's probably a planet where instead of an orange Trump, they've got a green green Trump, right? But it's otherwise very similar. Yeah, no, absolutely.
That is why I've been speaking about it for a little while, but I'm really hoping that this year we're going to start a little spin-off of the Honest Government Ad series. I'm thinking of calling it the Department of Climate Shitfuckery, so that we can really focus on this issue and give it the attention that it requires, so that we can really help climate scientists get the word out. So hopefully we'll be doing that, and I don't know, it'd be great to have you on the show again. But either way, thank you so much for your time and everything you've contributed while you're here.
No, thank you, Giordano. It was very much a pleasure talking with you, and I very much look forward to seeing that happen. And I'll be happy to help out in any way I can. So best of luck with that effort. Thank you.
One thing that I'm trying to make a habit of doing now when I do these interviews, I'm still learning kind of thing, but I've learned to ask people, is there something particularly that you want to get out, like that that we didn't cover?
I did want to make one final point here, and it's an important one. It's a serious one. It's time for the shitfuckery to stop. Okay.
I'm glad we got that on record.
Yes, I figured it was important to establish that once and for all.
And that brings us to the end of episode 9 of the Juice Media podcast, which has been part 2 of our companion podcast for our Honest Government ad about the fires. There was just so much to say, and I think you'll agree that splitting this up into 2 podcasts has allowed us to really get into more depth in 2 separate but kindred conversations. One about the situation that we're in from a scientific perspective, and again a reminder of how important it is to actually give the mic to climate scientists when having these conversations. And the other podcast, episode 8, which if you haven't listened to, I really encourage you to go back and check it out, which focuses on the technological solutions at our disposal right now to avoid this shit show and potentially the Great Filter. If there was one thing I could ask you to do, if you enjoyed this podcast and found it useful, please recommend it to your friends and family so we can get more people to listen in to the voices that need to be heard as we get deeper and deeper into the climate emergency. If you absolutely loved our work and want to support it, of course you can do so. Head to patreon.com/thejuicemedia and sign up. A huge shout out and thanks to all our patrons who make it possible to make this podcast and our Honest Government ads. This is Giordano. You've been listening to the Juice Media podcast. We'll catch you very soon for our next Honest Government ad. Take care.